Hello and welcome back to our channel. Today we are bringing you a different kind of video. We would like to explain spider diagrams that one often comes across in various white papers and reports. People often ask us during trainings how they should be read and interpreted. Here is a very simple explanation. So, what are spider diagrams? Spider diagrams, also known as spider charts or radar charts, are useful when two or more items need to be compared, and each of these items has three or more quantitative variables represented on axes starting from the same point. Let's understand this by a simple example of rain. City A gets moderate rain, really gets flooded and harvests all the water. City B gets lots of rain, gets flooded all the time, but also harvests water. City C, on the other hand, gets lots of rain, does not get flooded, but does not harvest the water. So let's start drawing spider charts for each of the cities. Remember, we have three variables: rain, flooding, and harvesting. We can represent using a triangle. For City A, we can see that it has moderate rain and all the water gets harvested. It also doesn't get flooded. City B gets lots of rain, gets flooded all the time, but also harvests water. We are showing that 60% of the water gets harvested. City C is interesting. It's like City B, gets lots of rain, but it does not get flooded and does not harvest water. So hopefully this example gives you an idea of how spider charts work. So now let's start with an empty 5G spider chart. In this presentation, we will look at 6 variables only. We could look at lots more, but we are going to restrict it to 6. Starting from low latency and going clockwise, we have reliability, peak data rates, coverage, low cost, and battery life. So let's start with a 5G enhanced mobile broadband or an eMBB spider chart. For eMBB, we are looking at a reasonably low latency and a reasonably high reliability. We are looking at very high peak data rates wherever possible. The coverage is important, but not very important. We are looking at very high peak data rates in small cells. We are not thinking about nationwide peak data rates. The cost for eMBB devices like smartphones are quite high. We are not thinking about low cost at all. Again, battery life is not high on our agenda. Most people are happy to charge their smartphones every day. So this is roughly how the eMBB spider chart looks. Now let's carry out a similar activity for 5G URLLC or ultra reliability and low latency communications. Note here that the highest priority is for low latency and very high reliability. So you can see low latency and high reliability. Peak data rates are not very important as we are looking at URLLC more for mission critical IoT kind of applications. We are looking more at localized coverage rather than wide area coverage. Cost is not an important factor for URLLC. Again, there is no need to worry about battery life. So hopefully this URLLC spider chart was clear and easy to understand. Now let's do the same activity for LTE-M or eMTC. Low latency is not important. High reliability is not important either. The same with peak data rates. Coverage is very important though, as the message is expected to reach the base station whenever it's transmitted. Again, low cost of the transceiver module would be very important as we are expecting a very high number of IoT modules to be deployed in the future. The same with battery life. It's important to have a long battery life, but as long as it's reasonable, it's okay. There is no single number as to what the battery life for a LTE-M device should be. It depends on the use case and application. For example, a pet tracker kind of device could be expected to have its battery last for at least a couple of weeks, if not a month. Now let's look at NB-IoT. In a way, it's very similar to LTE-M, but has a more critical requirement for an even longer battery life, 10 years in some cases, and very low cost. So here is the spider chart very quickly. Note that an NB-IoT device is expected to send very small amounts of data. Having put all the spider diagrams together, we can now visualize the different requirements for eMBB, URLLC, LTE-M and NB-IoT. In the case of LTE-M and NB-IoT, it's fascinating to see how they have slightly different requirements. This is important as many people often wonder what was the point of having two separate IoT technologies defined by 3GPP. So we hope you liked this short and sweet presentation on understanding spider diagrams or spider charts. We wanted to cover this because it will come up again in our next topic, NR Lite. Once again, comments and feedback are very much appreciated. Thank you.